kilograms. And so the acceleration for the electron is 2.11 times 10 to the 15th meters per second squared. So from here we can take these values and we can plug them in to this equation in order to find the times for each of them. So we have over here, so our equation is root 2 change in x over the acceleration to equal the time. And we'll plug in the acceleration for the proton first. So root of 2 and then the change in x is 0.05 meters over 1.15 times 10 to the 12th meters per second squared. And so that's going to equal the time. And so the time for the proton is 2.95 times 10 to the negative 7. So that's the change in time for the proton. For our electron, we've got our acceleration here, and then on top of that is 2, and the change in x, which is 0.05 meters, square root. And we could put a positive and negative into this, but it doesn't really matter in this equation since we're only solving for time. And so when we multiply all of this out, the answer that we're left with is 6.88 times 10 to the negative 9 as the change in time for the electron. What we do from this point is we take the change in time for the proton and subtract the change in time for the electron from that. If the change in time that we're left with is positive, then we know that this value, since that's the value, the first value in the subtraction problem, we know that that's larger and that the electron got to the other plate faster. However, if it's a negative number, then we'll know that this value got to the was larger, therefore meaning that the proton got to the other one faster. So we've got 2.95 times 10 to the negative 7, and then that's in seconds, and minus 6.88 times 10 to the negative 9 seconds. We subtract those, and the answer that we are left with is 2.88 times 10 to the negative 7 seconds. Now, since this is a positive number, we can figure out that the proton time was larger, therefore meaning that the electron got there first. And so this is our final answer. Now we're going to move on to the last problem, number 10. In question number 10, we have a 1.5 microgram mass with a certain charge that's between two parallel plates that have different electric potential energies. And so in our givens, we know that the change in voltage is 60 volts because over on this plate it's 60 and over on this plate it's 0. So the change is 60. The charge, so I'll just put a Q, the charge of the mass is 5 times 10 to the negative 9 coulombs, because a nanocoulomb is 1 to the negative 9, or 1 times 10 to the negative 9 coulombs. And then for the mass is 1.5 times 10 to the negative 9 kilograms. Now, if you look at your equation sheet, the conversion factor for going to micrograms is times 10 to the negative 6. But that is if you are starting in grams and you're moving back to the micrograms. But since in physics we deal primarily starting with kilograms, that's another 3 zeros to add on to that you're going backwards. So the total thing is to the negative 9 power. Alright, and the unknown, the thing that we're trying to solve for, is the velocity. And I know there's two v's in this, but the velocity of this particle when it hits one of the other plates. So the equation that we're going to use is the velocity is equal to work over charge. The work in this case is that W, or the kinetic energy, because this is in joules, is equal to 1/2 mv squared, just because we're trying to find the velocity. So what we end up doing is we have, if I put all this together, we have V is equal to mv squared over 2q. And that's just because this 1/2 goes onto the bottom in the fraction. What we do from here is we try to isolate the velocity. So we end up with 2q and then the voltage over the mass, and all of that square rooted is equal to the velocity. So from here all we do is plug it in. So 2, and then the charge is 5 times 10 to the negative 9 coulombs. And then the voltage is 60 volts and over, and we've got meters, or the mass. And we've got the mass, which is 1.5 times 10 to the negative 9 kilograms. When you multiply that out, the answer that you get is 20 meters per second. And I know I blew through that one really fast, but there's only one equation that you can use for this, and the only real hard part about this problem is figuring out the units and what unit is what. So, as always, I hope that these tutorials helped you guys out. If you have any questions, comments, or concerns, just shoot us an email at our email, which is listed right here on the page. Or you can go to our website and fill out the form there on the Contact Us page. See you next time.